But today we'll be kind of considering that, okay, let's say the CPU is only made of execution unit and register unit, and we'll try to kind of understand that. So our whole focus for today's session will only be in this part, which is the register value. Okay. So if we are able to kind of understand the register value in a deeper sense, we'll be kind of understanding how the pen testing, how the exploit writing, everything works at a kind of real sense, and how attacker actually does the exploitation um, uh, in depth. Okay. So our whole focus today will be just on the register part, and we will not be kind of worried about the other parts, which are the other memories. Okay. So with that in mind, let's start further discussions. So that is all about this slide. So now let me go to the next slide. Okay. So now, as I was telling that the CPU register is made of multiple units. So this part where I was telling you that, okay, there are different kind of memory slots available where you can store the data like EAX, EBX, ECX. So let's see that in much more sense. So the thing is that, guys, whenever you want to kind of understand the pen testing and how the pen testing is kind of working at a very in-depth level, at a background level, so normally thing is that you need to understand the registry. If you are able to kind of, as a pen tester, the whole idea of any attacker of any tool is to have an unauthorized control of the register values. Okay, so this is where the whole game is all about. Pen testing or any kind of exploitation that happens, the whole game is only in this part, the register. If you are able to control the memory slots data by any means, then you are the winner. Okay. So we need to kind of understand the register, and that's it. If we are able to kind of understand that thing, we will be able to kind of, and if we are able to kind of control what data goes inside this memory slots, this is the one where the whole pen testing world or whole exploit writing world is all about. It's all about controlling the value of this register. They are not worried about control in it. They are not worried about execution in it. They are all worried about the register values. Okay. So we'll now look at the register value in much more detail. Okay. So register value, as I told, that it is kind of made out of components. So for an example, so what are the components over here? So there are, let's say, 4 different kinds of memory slots. So the first kind of memory slots is which we can say it's as general purpose register. Okay. Then the next slot is segment register. Then the next memory slot is instruction pointer register. And then the next kind of memory slot is control register. Okay. So our goal is basically to kind of have control of this part, the general purpose register. So what I mean to say is that normally during the pen testing, our goal is basically to control this part, the general purpose register, as well as this part. Okay, so even in the register, we should be more worried about, so the exploit writing and pen testing normally is all about controlling this data, and the main data that needs to be controlled, it's always this one. So this is the most important variable. Okay, that's where the whole game of pen testing or exploit writing is all about. It's controlling this memory slot. The name of that memory slot is EIP. Okay, it's also called instruction pointer register. And what's the role of this instruction pointer register? The role of this is, let's say, when you are executing, when any code is executing, let's say this code is executing, for an example, A equal to 10, B equal to 20, A equal to A plus B. So what is happening is that this code is executing. The data of A equal to 10 is being stored in the EAX register. The data of B 20 is, let's say, stored in this EBX register. And register, I mean Just think of it kind of a memory slot where you can store the data. That's it. Okay. Now, what this EIP is all about. So thing is that what the role of this EIP is all about is that when the CPU will be executing this line A equal to 10, what is the next line? What is the next line that needs to be executed? That information is stored at the same time in the EIP register. So let's say the address of this line is, let's say, 1, line number 2, and line number 3. Okay. So what we do is that when the CPU is executing A equal to 10, that time the EIP value will be 2. Okay. When the CPU will be executing B equal to 20, that time the value of EIP will be 3 at the same time. And what's the reason? The reason is that the next line that needs to be executed, the CPU will refer only to the EIP register. Okay, only to the. So here now the CPU will see that the next line number is 3. So it will execute the next line, which is A equal to A plus B. And before doing that, it will also store the next line, which is 4, let's say. Okay, that means the next line that needs to be executed is this one. Okay, so the thing is, why I am telling the whole world of pen testing and exploit writing is all dependent on the EIP register is because, let's say, this is the normal code that needs to be executed, and let's say there's an attacker and they have their own malicious code over here. Okay, own malicious code over here, and let's say one of the code over here is connect to malware server, for an example. Okay, so let's say one of the code of the attacker is all about connect to malware servers. Okay, so what will happen? Let's say this code also has line numbers, like line number A, line number B, and then this line connect to malware server. Let's say the line number of this is C. Okay, so why I am always specifying why the EIP register is all, the whole story of pen testing and spy writing is all about controlling the EIP register. The reason is that what the attacker can do is that using some kind of vulnerability, what they will be doing is that when, let's say, the code B equal to 20 is about to be executed, which says the line number is 2, what the attacker will be doing is that when the EIP at this moment of time should hold the value 3, they will be exploiting some kind of vulnerability. Okay, they will be executing some kind of vulnerability, and they will control the value of EIP in such a manner that the EIP value, rather than being 3, it gets changed to C. So next time what will happen now is that once the CPU is done with executing B equal to 20, the instruction pointer, let's say the attacker somehow was able to write the line number C rather than 3. So then the CPU will start executing this line, the C number. Okay, so rather than executing this all data, what the CPU will be doing is that it will just follow the EIP value, and it will start executing this line which says connect to malware server. And then what will happen? The computer will initiate a reverse shell to the malware attacker server, and that's where the malware attacker is able to kind of, let's say, get the full control of the system. Okay, so I hope, guys, till this point there is no concern, like what I'm trying to showcase to you guys. So this thing will be definitely very complex. So if you have any questions, feel free to kind of interrupt me and at any moment of time. So I hope you guys have understood at least till this point. There shouldn't be any issue. Let me know if there's any kind of question till this point. I'll wait for 10 seconds. Okay, so I hope this was easy to understand, like what's the role of CPU register over here. So we are all worried about controlling the values of this memory slots, and the most important, the hero of this register is EIP. Okay, this is the most important slot, that everyone wants to control right now in the world. Okay, just to get